The region below is bounded by 5x plus y equals 8, x equals 0, and y equals 0. So that means this equation is that straight line right there. Okay, and then we have x equals 0, y equals 0. So it says set up the definite interval required to find the area of the shaded region integrated by integrating over the x-axis, then find the area. In other words, they want to see how this has dx, so they want us to go right, left. I mean, I know that might, well, I'm going to the right. See that? I'm making slices sideways. Well, I know that might seem like very, well, I'm making vertical slices, but as I move to the right. So that's dx slices. So let me put one in there and we can take a good look at it. So basically what this means is we're looking for slices like this. Like that. Okay, that's it. How do I know that's a dx is the width of that? Okay. And then what is the height? How do we know the height of that little rectangle? Well, the height is y, right? It goes up to the y coordinate. And y, if we take this equation, 5x plus y equals 8, if you bump this to the other side, y is negative 5x plus 8. So there we go. So we're going to go, so this is the height right here. And that's the same thing as negative 5x plus 8 or 8 minus 5x, same thing. Dx is the width right there. So we have the height and the width. That's how you find the area of a rectangle, right? Height times width tells you the area of a rectangle. So we're saying we're going to have a whole bunch of rectangles. Their height is 8 minus 5x or minus 5x plus 8, either one, times the width is dx. That's the thickness. A bunch of those rectangles, and we're going to add them up from starting right here at 0 all the way to what? Starting at 0 all the way to what's that going to be there? Well, how do we find that spot? Well, that's where this equation, this line equation equals 0, because this point is got a y coordinate of 0. Let's find the x coordinate. So let's solve for x. So bump that over. And so we get minus 5x is minus 8. Divide by minus 5. Boom. X is positive 8/5. So this must be positive 8/5. That's why we go from 0 to positive 8/5 of this function, which is the y height. Y alone is minus 5x plus 8, or a minus 5x, same thing, times the width dx. And now we have to actually do that integral. So let's actually do that integral. This is kind of a long problem. So I'm going to do that integral. So bring this one up here. So that's going to be the integral from 0 to, I'm going to make this 8/5 into 1.6. Check it on your calculator. 8 minus 5x dx. So this is going to be the antiderivative. This is 8x minus, this is the first power, add 1. That'd be x squared, divide by 2. Evaluate that thing between 0 and 1.6. So if I plug in 1.6 there and there, I'm going to get 8 times 1.6 minus 5 halves times 1.6 squared. And then you plug in 0, boom, boom, you're going to get minus 0, minus 0. It's not going to do anything. So 8 times 1.6, let's go to Desmos. 8 times 1.6. So we're right here. 8 times 1 minus 5 halves times 1.6 squared. Minus 5 halves times 1.6 squared equals 6.4. And that's what this is. This is 32/5, same thing. It's also 6.4. All right. So we get that answer. Now, the second part is where things get a little more tricky. In the second part, they want us to set up the definite interval required to find the area by going dy. So now, instead of going sideways like that with these things, we're going to go the other way. So now we're going to take that graph and let me get rid of this work right here. And I want to put them like this. I want to go that way, right? We're gonna chop it up. This, how do we know? Because now dy is the height of the rectangle. So we're gonna come there, and now we need to find what is the width. Well, the width, this is the x coordinate. That's the x coordinate, right? Because that's what it means. Whenever you go from the axis over to the graph, that's called x. A minute ago, we went from the axis up, and that was called y. So that means I need to take this equation, 5x plus y equals 8, and I got to find x. So let me bump this over. So 5x, I'm trying to get x alone because I need x here. And this y plus 8 divided by 5 all the way through. Got to go all the way through there, right? So x is minus 1/5 y plus 8/5. I'm going to make that 1.6. In fact, I'm going to make this a fraction as well. Make that minus 0.2. That's what it is. So there we go. That's what x equals. So I'm going to put that down here. They wrote it differently, but I'm going to put this right here. Minus 0.2y plus 1.6. It's the same. If you took both these and divide by 5, you get the same thing. Times dy, because again, the dy is the height, and this is the width. See how we're doing that? So for each of these rectangles, the width is just x, and x equals that. When we took that equation, and right, this is the equation of this line. If you want to know the x coordinate on that line, how far over to this line, find x, get x alone. It's that. The height is dy, so the area of this rectangle is x times dy, but x is this times dy. And then where are we going? We're integrating this from the bottom, which is 0, up to the top. What is the top? How do you find out what that top is? Well, that's going to be up at 8. How do I know? Because when x is 0, this is the point over 0 up 8. When x is 0, y is 8. How do I know? Plug in 0 there for x, y just equals 8. So that's the point up 8. So we're going from 0 to 8. We're integrating. This is a dy integral along the y-axis. Going up, 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 up along the y-axis. The dy is the height, and the width is x. We solve for x. There we go. So this is the x. The width is, again, x. And x equals this times dy. And now we're supposed to carry out the integral, but look, I'm not going to bother. It's going to be the same answer. These have to be the same. Why? Because they're the same area. We're just slicing it two different directions, right? The blue or purple, whatever that is, area is 6.4 or 32/5, whichever way you do it. You can slice it this way or slice it that way. It's going to be the same. So I'm not going to bother to do the other integral. It'll come out the same. If you carried this out, it would come out to be the same exact answer. So there we go.